Alright, let's attack this dude. It's from 2002. We have another related rates problem right here. Number 5, question number 5. So a container has the shape of an upright, an open, right, cylindrical, circular cone. As shown in the figure, there it is above, actually it's to the right because it's a SG. The height of the container is 10. I can see that in the picture. 10 centimeters, and the diameter of the opening is 10. I can see that in the picture. Centimeters. Water in the container is evaporating, so that its depth h is changing at a constant rate of -3/10. Oh, hey, that's kind of cool. They told you it was negative. Sometimes they don't tell you if it's a negative rate. Since this is changing the h, we know that the h is decreasing because the rate is negative. Okay, just identifying things. Actually, let's write something next to that so we make sure we know this is dH over dt. Okay, that's our dH over dt. Okay, let's see. The volume of the cone of height h and radius r is given by this formula. That's so nice. They give it to us. Find the volume of the water in the container when h equals 5 centimeters. Indicate the units of measure. Just finding the volume? Oh, dude, that's just plugging stuff in. All right, this is an easy one-pointer. Here we go. We got V equals 1/3 pi times the radius squared, and then the height. Oh, and there's the trick. There's the problem right there. We don't have a radius. Oh, sticky face. All right, so what we got to do is we got to somehow set up another equation so that we can get rid of that r, so that we only have h's. Okay? Did I rewrite? Right? Oh, I'm supposed to plug in 5. Yeah, I'll fix that. Hold on. Okay, so for the cone, look at this triangle right here. You guys see this triangle I'm just outlining right there? We have the height of that triangle, which is h, and we have the radius, or the base of that triangle, which is r. So we have h over r. I'm going to create a little proportion here to make another equation. And then there's another equation here that you can't see very readily because there's no lines to show it. You see that triangle right there? What is the radius of this triangle? 5. And what is the height of this triangle? 10. So we have, which one do we have on top? The h? Okay, so that means I'm going to say 10 over, what was it, 5. Okay, so actually that's just 2, so that simplifies to 2. So we can simplify this dude a little bit. We have h over r equals 2. So it's almost like we have a system of equations. We're trying to get the r alone here so that we can sub it into there. If we can write r in terms of h, did you hear what I said? If you can write r in terms of h, this problem just became a lot more simple. So if I'm writing r in terms of h, I got to get the r alone. So you could think about it like multiplying both sides by r. So now h is written in terms of r, but I want r in terms of h. So I'm going to have 1/2 with the h and the 2 gone from the r. So r equals 1/2 h. So instead of writing an r, we could write, actually I'm going to put that pi on top, pi over 3, and then that's 1/2 times h. And then we have our 5 right here. Don't forget to square that. And what is h right now? H is 5. Okay, so half of 5. So we have 5 over 2. So we have pi over 3, 5 over 2 squared times 5 over 1. Now there's definitely other ways to do this. This way might be the hard way to you, I don't know. But I am going to show all my work to make sure you guys are all following me. Okay, so I went 5 times 5 on top, 2 times 2 on bottom because it says squared, and I have to multiply this thing by 5. Nothing to simplify. Boo. I really want to simplify some stuff. 5 times 25 is going to be 125 pi, and on the bottom we're going to have 12. Alright, so this is our volume. Oh wait, it said something about units, right? Okay, I gotta say units. What are the units? Oh, centimeters cubed. There it is. That's your volume. Let me read the question again, make sure I answered it because I totally forgot what we were doing. Find the volume of the water. Yes, we did that. When H is 5, indicate the units of measure. All right, we did all that stuff. All right, let's look at letter B. Find the rate of change of the volume of water in the container. Wait, isn't that what that is? With respect to time, when H equals 5, indicate the units of measure. So here, since we're looking for the rate of change of the volume, that's dH over dt. That's the rate of change of the height. We're looking for dV over dt. So let's write that down. We got dV over dt. That's what we're looking for. Once you identify the rate, your goal is to find an equation that has that variable in there, that v, and then you can take the derivative of it. Now what's really nice is that we actually have an equation of volume that does not have the r anymore, which is probably what we want. Actually, it definitely is what we want. You know why it's what we want? Because we don't have a dr over dt anywhere. We have a dh over dt. So here, let me write and talk at the same time. We have, this is our volume right here. We have pi over 3 times r to the third h. Okay, if we took the derivative of this with respect to t, I don't know if I can write it on this side, but I am. We would get a dr over dt. You would have to do the product rule with the r and the h because they're multiplying, and you would get a dr over dt. You can't have a dr over dt. Wait, I wrote a 3. Is that a 3 or a 2? That's a 2.
Where?
What am I doing here? I'm surprised none of you guys caught that. You're not fast enough. Okay, so what we need to do is we need to get rid of that r. Let's write r in terms of h, and so we're gonna put I'm gonna put h over 2 right there, and we're gonna square that, multiply it by the other h, so we can get rid of that r. I put h over 2 because that's what 1/2 times h is. The h just goes on top. You know, you put h over 1, blah blah blah. So if I square this, that's going to be h squared over 4, h squared times h. Actually, let me write it out. We have h squared over 4 times h, and we have a pi over 3 right here multiplying to this. I still want to simplify some stuff here. Let's make this an h to the third, get rid of that h, and I'm gonna take that h to the third off of there. So we have a 1/4 times pi over 3, so then we have pi over 12 h to the third. Wow, look how pretty that equation looks. That is way nicer. Alright, let's take the derivative of this with respect to t, shall we? We shall. So when I do that, I first take the derivative of v. What is the derivative of v? Uno. But then, since we're taking the derivative with respect to t, we have to then write dv over dt, which is the same as v prime. On the other side, we have pi over 12. Now remember, pi is not a variable. That is a constant. That's a number that we know. We have to take the derivative of h. There's no product rule here, just an h. So we drop the 3. The 3 multiplies to the pi over 12, so we get 3 pi over 12, and we do have simplifying there. We have h to the second power, because we take one away after we drop one. But then we have to write dh over dt. Why? Because we are taking the derivative with respect to t, not h. Alright, now, what are we looking for again? Oh, that's right, dv over dt. So that means we must have an h, and we must have a dh over dt. These are variables right here. We need to know those numbers. Do we know what h is? It is 5. And so I'm going to plug 5 into there. Let's plug a 5 into that thing right there. And then what is dh over dt? Negative 3 over 10. Very good. Guys, you don't have to all answer at once. Calm down. Alright, I'm going to simplify this at the same time here. We have pi over 4, and we have a 25 that we're multiplying to that, and then we have a negative 3 over 10. I'm going to go ahead and multiply this out. I don't think you have to have this multiplied out on the College Board exam, but I'm going to do it anyways. 25 times 3 is 75, so I have negative 75 pi on top. On the bottom, I have a 40. Alright, that is our dv over dt. Don't forget our units. Does it ask for units? Indicate units of measure. Yes. Okay, so then we have, what is this, volume? So we have centimeters cubed per what? What's our time units right now? What does it say? What does it say? Hour. Hour. There it is, right there. You see that? It says centimeters per hour. Alright, so we got centimeters cubed per hour. And we do this little thing right here where we box it, and we're done. We found the answer to that problem. Yes, I can simplify this, but I'm not going to. Last question. It says, show that the rate of change of volume of the water in the container. So that's dv over dt. Let's write that so we know what that's talking about. show that the rate of change of the volume of the water, that is dV over dt, in the container due to evaporation is directly proportional. Directly proportional. Let's squiggly underline that. Directly proportional to the exposed surface area of the water. Exposed surface area of the water. What is the constant of proportionality? Alright, now if you want to know the constant of proportionality, you have to understand what that means. Let's pretend we have this number A. A is proportional to B if I do this. So that's B and that's A. A is proportional to B. If I have this K multiplying to B, I would get A. So like, let's pick two numbers that could be proportional to each other. Let's see. 5 is proportional to 10. What is the constant of proportionality here? What would K have to be in order for this to equal 5? 1/2. Okay, so that's what it's talking about when it says constant of proportionality. All right, so we're trying to show that that dV over dt is directly proportional to the exposed surface area of the water. So what is the equation for the exposed surface area of the water? Now, as soon as I wrote this, pi r squared, I remember seeing pi r squared somewhere. Do you guys remember seeing pi r squared somewhere? Right there. Pi r squared is actually in the volume formula. So volume is proportional to pi r squared. It's a 1/3 times the height. That would be your constant of proportionality. But we're not supposed to compare it to volume. We're supposed to compare it to the rate of change of the volume. So I look over here at the dV dt. Let's write what dV dt equals. We found it earlier. dV dt equals, what is that? It'd be pi over 4 times h to the second power, and then dH dt. Okay. Now we know the dH dt. The dH dt is -3 over 10. So let's put that in there. Let's instead of dH over dt, let's put -3 over 10. And let's simplify this a little bit. We have -3 pi over 10 times h squared. Okay. Now I didn't take out the h squared because that h squared, I could probably make that h squared look like so this side looks like pi r squared. So how can I make, oh yeah, let's just sub it back in. What does h equal? Thank you for that. Yeah, I don't know why I did go 4 times 10 right. Okay, what does h equal? H equals 2r. I look over here at my other stuff. Right here, h is 2r, so I can plug 2r in there. And let's see what we get. We get -3 pi over 40. Then we have 2r in there that's getting squared. Well, let's square that really quick. We have 4r squared times 3 pi over 40. Okay, so if we simplify this a little bit, I'm going to cancel this 4 and make this 40 into a 10. And then we have it. You guys see the pi and the r squared? Let's take the pi off the numerator. That is -3 over 10 pi r squared. And what does pi r squared equal? It equals A. I wrote that up here. A is pi r squared. So what is the constant of proportionality? It is the number multiplying to the A. Alright, make sure I spell constant right there. Yep. I ran out of space. Proportionality, whatever. Alright. That's it. That's how you do it.